this podcast, we're going to learn how to use the IUPAC naming system for ketones, and we're going to do some examples as well. All right, ketones are a group of organic compounds that have a carbonyl group in them, just like aldehydes, but instead of that carbonyl being on the end of a carbon chain, like an aldehyde, the carbonyl is going to be between two other carbon atoms, so we would consider it in the middle. So here you can see our carbonyl is in between two R groups. So R represents 1 carbon to 5,000 carbons, although that is not likely. It represents a carbon chain of any length. So now it's in the middle. We also see this abbreviated as an R group with a CO bonded to an R group. If you were to think about this, your carbon would have to have a double bond to oxygen, or there would not be enough valence electrons and you would not be satisfying the octet rule for your carbon. Sometimes I see it even further abbreviated as R2CO. I guarantee you will not see this in our class. I just want you to know that there are different abbreviations for this. All right, so we're going to begin on naming where we always begin. You are going to start by selecting the longest continuous carbon chain that contains the carbonyl. You're going to use the parent alkane name based on the number of carbons, and you're going to change the ending to -one. So for example, if this is butane, 4 carbons with a carbonyl in the middle, then you are going to call it butanone. You're going to number the chain from the end closest to the carbonyl group. So you want to give the carbonyl priority and give it the lowest number possible. So that means you may have to count from the left to right, the right to left, up, down. Make sure that you're giving it the lowest number you possibly can. If you have a carbon chain that is 5 carbons or longer, you're going to need to indicate the location of the carbonyl. If you're not into memorizing how many carbons there has to be in order for this rule to be applied, just ask yourself, can this carbonyl be anywhere else? If your answer is no, it can't be anywhere else because it's a shorter chain, then you don't need to number it. If it could be in the 2nd position or the 3rd position or so on, then you're going to have to number it. All your previous rules are going to apply. So you are going to alphabetize all your branches, giving them the lowest numbers possible after your carbonyl, etc., etc. All right, let's do some examples. We'll start with this top left one first. We're going to find the longest chain that has the carbonyl, 1, 2, 3, 4. So we know that we're going to be working with butane as our parent alkane. Drop the E and change it to ONE. So this is butanone. In this situation, 1, 2, okay, we have the carbonyl on our 2nd carbon. It could be on this carbon here, but it would still be on carbon number 2. Butanone has less than 5 carbons, so we don't actually have to number the position of the carbonyl because it can't be anywhere else and still be a ketone. So butanone is the name of this one. All right, so the next one, we have to find our parent ketone chain. And so whenever you have a cyclic, it's going to be that one. So I like to identify with a circle what my parent chain is, so then I can see everything else as being branches coming off of that. If this were a cyclic alkane, we'd call this cyclohexane. Same rules apply. We're still going to call this cyclohexane, but we're going to drop the E and we're going to change it to ONE, cyclohexanone. Because we have the choice of where to start numbering, it gets carbon number 1 as a cyclic. I just need to decide, do I count clockwise or counterclockwise to give my groups the lowest number possible? And the answer is going to be clockwise. This gives me groups in the positions 3 and 4. So now we just worry about numbering those groups. And we have an ethyl group and a methyl group. Ethyl comes first alphabetically, so I'm going to write that first in the name. This is 3-ethyl, 4-methyl cyclohexanone. All right, in our last example, we're going to find the longest chain. I'm going to count 1, 2, 3, 4, 5. I'm just going to double check. 1, 2, 3, 4. That is shorter. I'm not going to use the blue route for this. Okay, so my parent chain is going to be 5 carbons long. That is pentane. Drop the E, change it to an ONE ending, pentanone. This time I do have to label the position. The lowest number carbon I can give it is 2. And following this green line, that gives me a group coming off of carbon number 3. So this is 3-methyl 2-pentanone.